Welcome back, everybody, to another lesson. Today, we are going to do inequalities with decimals. So, we'll start with our first example here. We have two numbers. We have 0.06, and then we have 0.58. We want to know which number is bigger. So which number is bigger here? Is it going to be 6/100ths or 58/100ths? Well, I think it's pretty obvious that 58/100ths is going to be bigger than 6/100ths, so therefore we would say 6/100ths is less than 58/100ths. It would be less than that. If you remember right, the gator's mouth opens towards the bigger number. So if it opens to the right, this means that the number on the left is less than. And if it opens the other way, it means that the number on the left is greater than the number on the right. But in this case, 6/100ths is greater than, is less than, rather, 58/100ths. I think that one's pretty obvious. Now let's get into some other numbers here. Say I give you 0.008 and then 0.8. So we have 8, this is 8 thousandths and 8 tenths. Which number is going to be bigger? Well, a good trick here, since the first number has 3 decimal places, the second number has 1, we can try to get the second number to also have 3 decimal places. So we're still going to be comparing 0.008, and then we'll have 0.8. However, after that 8, there's a default 0. We also have another default 0 if we want to get it to 3 decimal places. Because after the 0.8, there's just zeros all the way to infinity in every place after that. So now it can read 8 thousandths and 800 thousandths. Which number is bigger? Definitely the 800 thousandths. So we would say 8 thousandths is less than 800 thousandths. Then you'll say, therefore, with those 3 dot symbols, therefore 0.008 is less than 0.8. That would be how you write it. Therefore, 8 thousandths is less than 8 tenths. So basically you do your work and then you convert it back to the original inequality, and then you have your answer. Alright. Got 4 more here. How about 0.905 and 0.91? Okay, so we have 905 thousandths and 91 hundredths. Again, we have 3 decimal places on the number to the left. We only have 2 decimal places to the number on the right. So it would really help us to convert the number on the right to 3 decimal places. So we will still compare 0.905, and then we'll have 0.91. There's a default 0 in the place after the 1. That's how you would convert that to 3 decimal places. So now you have 905 thousandths and 910 thousandths. Which number is going to be bigger? Definitely the 910 thousandths. So we would write this as 905 thousandths is less than 910 thousandths. And then you would say, therefore, 0.905 is less than 0.91. That would be your answer. 0.905 is less than 0.91. Alright. How about, I got three more here. We have 0.99999, and then we have the number 1. So we have tenths, hundredths, thousandths, 10,000ths, 100,000ths. So we have 99,999 100,000ths in the number 1. Well, we don't need to do any decimal places with this one. We can see the whole number is 0. And no matter how many 9s we stick on there, it gets close to 1, but it never actually equals 1. So we can very clearly see that this 99,999 100,000ths is less than 1. That's an easy one, because it gets infinitely close to 1, but it never actually equals 1. Alright, now let's say we have a decimal and a fraction. We have 0.004, and then we have 4 hundredths. So what we have here, we have one number that's a decimal, one number that's a fraction. Well, it would probably help us if we convert both to decimals. We already have the decimal for the first one, which is 4 thousandths. 4 hundredths, if we remember right, is written as 0.04. That is 4 hundredths. However, the left number has 3 decimal places, the right number has 2 decimal places. Well, we want to convert the second one to having 3 decimal places. So you will have 0.004, and then you'll have 0.04, and then there's a 0 by default in the place after the 4. Because remember, everything to the right of that number, there's an infinite number of zeros. So now we are left with 4 thousandths and 40 thousandths. Definitely the 40 thousandths will be bigger. So 4 thousandths is less than 40 thousandths. So we would say, therefore, 0.004 is less than 4 hundredths. And that would be how we would write our answer. Therefore, 0.004 is less than 4 hundredths. Got one more problem here. Alright. Let's say we have 73 tenths. Then we have 0.73. So, again, we have one as a fraction, one as a decimal. It would probably be smart to make sure both are a decimal. So we start by converting the left number to a decimal. So that would be 73.0. And since we have a 1 0 in the denominator, we move the decimal place back 1. Which would give us 7.30. I'm just going to write the 0.73 here for good measure. And then we have 0.73. Well, we don't have to do a whole heck of a lot here. We see we have 7.30 and 0.73. We have a whole number of 7, a whole number of 0. We don't have to go any further. We can automatically go ahead and determine that 7.30 is greater than 0.73. Which would mean, therefore, 73 tenths is greater than 0.73. That would be your answer. So, if you have one number as a fraction, one number as a decimal, it definitely helps to make sure both numbers are fractions. Try to get the same number of decimal places for both numbers that you're comparing, and then you can figure out which number is greater than or less than. It's real easy. So, that's really all there is to doing these inequalities for decimals. So next lesson we are going to do estimating and rounding with decimals. I hope everyone has a good night, and I will see you next lesson.